Everybody, today we are going to start with the topic limits. Now, limits are the first topic you will study in calculus, and limits are actually used to evaluate functions where it is undefined. For example, let's say that f function of x is equal to x squared minus 1 over x minus 1. Now, I want to evaluate the value of this function when x is equal to 1. Now, you can do it simply by x squared is 1. So, it will be 1 minus 1 over, and x is 1, so it will be 1 minus 1. So, that will be equal to 0 over 0, which is not defined. So, how do we get the value of this? Now, we can use limits for that. And limits are actually a very good tool for evaluating such functions. We write the limit, the basic notation for this is the limit lim, and below it we write as x approaches some value, which is in this case is 1, and then we write our function, which is x squared minus 1 over x minus 1. So that will be equal to, now I'll tell you how to evaluate it. Now we know that x squared minus 1, we can factorize x squared minus 1 as x plus 1 times x minus 1. So x squared minus 1 over x minus 1 will be equal to x plus 1 into x minus 1 over x minus 1. So we can see that these x minus 1s just cancel out, leaving us with x plus 1. Now we can now put the value x is equal to 1 in this function. We get 1 plus 1, which is equal to 2. Now what this actually means is that when x equals 1, the function is not defined, but as x approaches 1, the answer approaches 2. Now we can show it graphically. So here is our graph, and seriously it took me a lot of time to draw this. Here is our y-axis, here is our x-axis, and y is equal to f of x, which is in this case equal to x squared minus 1 over x minus 1. So let me plot my graph. At 0, the value would be x plus 1, which is 1. Let me skip 1 for a moment. At the value of y, at x equals 2 would be 2 plus 1, which would be 3. At 3, the value would be 4. And at 4, the value would be 5. And so on. Now, we can join these dots to form a graph. Now, you might have noticed that I have left a hole at x equals 1. That's because the function is not defined here. As I've already discussed, that f of x is not defined at x equals 1, but the limit as x approaches 1, y approaches 2. And we can clearly see from the graph that when x is approaching the value of 1, y will approach 2, but it is never 2 because it is undefined at that position. So that's what limits are used for.